How's it going? Good? All right. You ready to accelerate and secure your development with DevSecOps and AI? Yeah? All right. Well, I wanted to talk about why. I'm Brendan Burns, and I'm here to basically give some context. I'm the CVP for Cloud Native and Management Platforms, and have generally been focused on open source and DevOps for over a decade at this point, really longer. The thing is that I think we're all aware of the fact that the threat landscape out there, whether it's from nation states or from ransomware or from any number of different actors who are trying to do malicious things, the threat landscape just continues to get worse. Right? So this shows the 180% increase in attacks following vulnerable software. This is really an important topic for everybody to be thinking about. And I think that's what really shows in the fact that there is this shared responsibility between developers and security folks to secure those applications. I think just like over 10 years ago when we started talking about DevOps, we were saying, hey, there's actually this shared responsibility between the people who build the software and the people who operate the software. As we're starting to talk about DevSecOps, we're saying that same shared responsibility extends between the developer, the operator, and the security manager, and making sure that all of those people work together. Because the thing is that in the past, I think security solutions haven't really been the developer's best friend. Right? Like in some cases, they're actually at odds with one another. And it's true that there's a balance between security and usability, but I hope that through DevSecOps, we can connect the dots from the source code all the way through to the deployed application to show how you can actually maintain good agility while also maintaining good security. So we're going to have to take all of these pieces of the developer workflow and integrate security into each and every piece of them. From code where there are vulnerabilities in libraries, to secrets that are accidentally committed into repositories, to dependencies where you may have either vulnerabilities or even malicious code that is being contributed in some cases to open source repositories. That's been in the news lately. And then obviously in this new world of containers, we're reinventing what it means to be secure and how you can build secure applications using cloud-native open source. And this is essential because we need to move to a world where finding a vulnerability means fixing a vulnerability. We need to have this idea that it's not a long list of, what are the thousands of different things that I need to patch someday, but rather the minute that a scanner or a security team or anyone else identifies a vulnerability, that the developer has what they need to fix that vulnerability, upgrade a dependency, fix a piece of code that has a bug in it, patch a container image, or identify misconfigurations of their Kubernetes clusters. And all of that needs to come together to reduce remediation time. And we think we can get it down under a half an hour. Which is amazing, right? If you think about how long it takes sometimes, even with things where there was urgent attention, like Log4j or others, it was measured in days, not minutes. And we really think by focusing on connecting all of the dots of this security lifecycle, we can really reduce that remediation time. And so the pieces that we have within the Microsoft portfolio, I think, are unmatched within the industry. I think this is really true for all of the DevOps and DevSecOps work that we're doing, whether we're talking about GitHub Advanced Security, Azure Container Registry, Defender for Cloud. They all come into this DevSecOps product portfolio, and we're integrating them together so you can achieve secure solutions for all of the applications that you're deploying. They come together like this in the DevSecOps lifecycle. And of course, we are using copilots as well to go from code to Copilot-powered scanning and remediation, to continuous integration with auto upgrades, to deployment of those auto-patched images, and then obviously closing the loop with runtime monitoring of the applications that you've deployed in case vulnerabilities happen while the application is deployed itself. And so to kick us off with all of that, we're going to focus on code. And I'm going to invite out onto the stage Brittany O'Shea from GitHub Advanced Security, who's going to talk to you about how copilots help patch code. Brittany. There you go.
Thanks so much. So Brendan just perfectly teed up some of the challenges we've traditionally had with securing our code or engaging developers in securing our code. But I want to start with a little bit of an icebreaker. So raise your hand if you're using some kind of vulnerability detection scanner today in your organization. Looks like all of us, great to see. Raise your hand again if you have fixed one of those vulnerabilities detected by one of those tools. A vast majority. So I want to see from a just rough poll timing, how many of you have fixed that in under 60 minutes? No hands. Common challenge that we have today is just fixing the vulnerability takes a lot of time and effort and education and requires us to do hard trade-offs against building new features, building the things that our customers want, and bringing the innovations we want to focus on to market. We are committed to changing this. We believe now with the power of AI, we can give more acceleration to the way we secure our software, and we can take away some of those traditional pain points. Over the last year, we have shipped more than 100 enhancements to help you better secure your code, including AI detection and AI remediation. And I'm excited to dive into just a few of those features, like Copilot Autofix, which is now generally available, that can help you accelerate and overcome some of those challenges maybe you are facing today or have faced in the past. So let's start with Autofix. Autofix is supported for all CodeQL languages across more than 90% of alerts. What it does is it provides a unique to your organization, your code snippet to help actually remediate the vulnerability detected within your organization. Let's jump in and see it live. So my colleague Nick here has recently added a new server, and we have scanning devices that are automatically connected within GitHub to make sure that when we commit new code or make a new PR, it's secure. And so code scanning ran CodeQL against this code, and it found out that it had a couple vulnerabilities. Now, before, the developer would have some information around this. They would have the ability to communicate back to their security team. Either maybe this is something they won't do right now, or it's used in tests, or it's a false positive. But now with Autofix, you'll get a unique description that your developers can understand about the vulnerability. And you'll also get a suggested change, which you can either open in a workspace to edit or refine, which we find is common. Folks want to have that control over their code. Or you could commit that session right there. And once you click that commit button, it's not like it goes off into ether. We'll rescan all those tests, ensure everything is secure, nothing has been missed, and you'll save hours of time for developers there. It's really powerful when we look at the stats, just the transformation over the past 6 months that Autofix has made in organizations like yours. Across all types of alerts, all languages, all complexities and severities, we've reduced the average time to fix from 1.5 hours down to under 30 minutes. That's a 3x reduction. And when we look a little deeper about certain classes of vulnerabilities that we've seen just have plagued the industry for 10s or 15s of years, like cross-site scripting or SQL injections, we've seen reductions as big as 7 or 12x. We're so excited about the time savings this is going to give you and your team back to help you focus on the things you love to do. But I know what you might be thinking at this point. Numbers are great, and they show, at a high macro level, some of the improvements, but they don't always reflect those challenges or that real-life experience that you're facing on the day-to-day. And it's easy to think about Autofix in the concept of, you might have a few findings, but the reality is there's a lot of steps you have to take before you actually get to fixing those findings. We knew last year we had to do better with helping you just simply to get started and helping to orchestrate that process. So we introduced code security configurations, which helps you roll out your detection at scale, set rules and policies that can protect new repos or new code projects that you have across your organization, and automate that from a manual process to a scalable solution that you can set over time. We knew this wasn't enough, though, and we had to do more with Autofix. Because if you're anything like organizations I work with all the time, you often have hundreds of thousands of alerts. You might have alerts that existed before you've even joined the organization. And you won't want developers just picking out of that bunch what to fix. You want to give precise information and guidance for them to target the security risk that's most important to your organization to help secure. This is where our new features that's just out this month, campaigns, come in. Security campaigns give you the ability to hone down on the security tech debt that's most important for your organization, and then seamlessly collaborate with your developers on fixing it. So let's see what that looks like in action. So if you're on the security team, you're probably spending a lot of your time in Security Overview or your other favorite dashboarding tool, and you're looking at your risk over time, what kind of alerts are propagating against your organization, and what you can do to change that. And like I said, if you're like my organization, you might have 160,000 alerts that have accumulated or compounded over time in your organization. And tackling that can be really difficult, especially when you have to often communicate with developers in spreadsheets, issues, all different types of forums that are hard just to get that process in place to fix. Well, now with campaigns, you can leverage either one of our out-of-the-box templates, like focusing on critical alerts, minor top 10 known exploitable vulnerabilities, SQL injections, cross-site scriptings, or you can create your own custom filters unique to your organizations across repository types, severity of alerts, and so much more. And then you can go ahead and create a campaign. So for example, if I wanted to create a campaign in my organization, I would be able to go in and set a description for that campaign or something like that. And you can run up to 10 campaigns at a time, which you just saw I hit that. And then I could set a campaign manager and track that progress over time. So here you'd be able to see from your view, once you set up that campaign, you'd be able to see how many alerts your team is burning down. You'd be able to see what that timeline is. You'd be able to see who's managing that, and maybe that's you, or maybe that's a security champion on your team. And then you'd be able to see everywhere your team is supported by AutoFix. And you can track that over time across repository. And the best thing yet is for developers, they can either jump into this view and start burning that down, or they'll get notified and they can jump into exactly an alert like they would see in their pull request, where they're prompted with that same description, that same AutoFix snippet for them to apply, and even more information for them to learn more about the vulnerability class, why it's there, different examples they can dig into. And this is so powerful when we think about many of the flaws that we're dedicated to fix might be 2 years old, 3 years old. The developer might not have been at the organization, might not have worked on this code, might not have introduced this vulnerability. And this gives them such a nice jumping off point to have a running start and giving them context into that environment and how to fix it without having to train from the ground up. Okay, so I know here, if you're getting excited, you might be thinking, but what about for tooling or languages that CodeQL doesn't support? We're big fans, of course, of CodeQL, but we know that most organizations use 1 or 2 or maybe even 3 different types of scanners to protect their code. And if you're using GitHub Advanced Security today, you know we've always been focused on extensibility. We have more than 100 different plugins with open source and commercial scanners that you can use today to give that same experience right in the PR from different scanning types. And we're excited to bring this to AutoFix as well. So now, starting today, new this month, we have AutoFix available for partners like JFrog, ESLint, or Synopsys Black Duck. And we're going to be extending this list aggressively to help you AutoFix any alert, regardless of the tool you're using, in the same developer flow, with the same context, to help remediation be seamless, no matter what combination of technologies you are using. So let's see just how similar that looks. So let's say that you ran ESLint on your code, and you wanted to actually fix what you were finding from there. You can see the only difference here you'll see is that instead of CodeQL, you'll see ESLint. AutoFix will still describe that problem unique to your code and your organization, and it will provide the exact same experience within the PR, where your developers can open a workspace, or they can edit the code here live, or they can commit this suggestion. Or they can communicate back with you as to why maybe not now is the best time to do that, giving you cohesive experiences, again, no matter what type of technology you're choosing. I'm so excited for the power this is going to provide to developers, for them to stay focused and in their flow, no matter what kind of feedback they're getting. But I know what you're thinking. There's more than just risks that we can detect with code scanning, and there's other tools like Dependabot. How many of you are using Dependabot today or some kind of SCA scanner? Looks like a good show of hands. Well, I like to think about SCA and what it's done and Dependabot as kind of like the original AutoFix. It was a way to upgrade and is still such a powerful way to keep our dependencies secure and up to date. And most of the time, it just works, and that's great. But we all know that some of the time, those upgrades or updates are not compatible with our code, and that can require refactoring. And that can make it hard to get off those non-secure versions. And if we think about the nature of supply chain risk, when we have instances like Log4j, for example, where we're all immediately focused on changing this quickly, getting multiple different versions we might need to update to, or we might be on multiple different versions currently across our organization. Imagine if that was with a breaking change. Imagine if you had to refactor all your code. The time it would take for us to respond to that could be overwhelming and damaging to our bigger business goals. We want to change that too with AutoFix for Dependabot, which is helping you to refactor your code when you have a breaking change on an upgrade from either a vulnerable or from a version change. So let's take a look on what that looks like. So now, similar to your AutoFix experience, I want to bump to a new version here, and that's going to create a breaking change. CodePilot AutoFix will still give me that same description, give me more information now that it's detected that breaking change for me, and it'll allow me to either edit this or commit that fix right there, taking what used to be a painful process of refactoring and making that seamless for me. Everything here you can get your hands on and start using, and if you're curious to get started today, we have a hands-on session where you can actually work with experts from the GitHub Advanced Security team and try it out. So if you want to join, please register and sign up. But I'm now going to pass it back to Brendan to talk about those next phases of the security lifecycle. Thank you.
Awesome. Thank you, Brittany. It's super cool to see what we're doing with GitHub Advanced Security. I wanted to move on from the code and improving the dependencies in the code to the artifacts that we build and focus on how we can do better continuous integration and continuous delivery of container artifacts. And with that, I'm going to ask Johnson Shee to come onto the stage, and he's going to give you a demo of our Azure Container Registry and container patching work. Here you go, Johnson.
Hey there. My name's Johnson Shee. I'm a product manager at Microsoft's Cloud Native Security and Registries team. As we all know, security and vulnerability management are not just the responsibility of your developers. Security doesn't just end with code scanning or secret scanning or PR security fix suggestions. Security and vulnerability management are also the responsibility of your operations and IT teams. Your IT teams need strong post-PR security practices so that the CI and CD portions of your DevSecOps loop is secure without additional manual overhead. Now, before we move on, could I get a quick show of hands of people who work primarily on infrastructure side of things? Pretty much the whole room. Do any of you deal with large numbers of vulnerable container images being reported in your fleet? Quite a few of you guys. Well, I'm sure you guys have dealt with the experience of security tools flagging vulnerable images across your registries and your Kubernetes fleets, but the vulnerable image has no fix available. We're talking about an open source image that you're forced to deploy and consume as vulnerable because there's no upstream fix available yet. Or we're talking about an application container image published by one of your partner development teams, application development teams within your company. But they're on a slower or a different release cadence, which means that there's no patched version available for downstream consumption. As an IT engineer or as a security engineer, it is very frustrating when you really want to get green, but you don't have access to the original source code to perform a full rebuild and redeploy of your vulnerable container images, right? We have a solution for you to secure the post-PR phase of your DevSecOps lifecycle: Azure Container Registry auto-patching. With Azure Container Registry auto-patching, you can allow your operations and IT engineers to instruct ACR to continuously scan and patch your existing stored container images without needing access to the container image's original source code. So with just one single registry configuration, your IT and security teams can ensure that your existing images have patched secure versions available for downstream consumption. This solves the existing problems that I described earlier. So how does Azure Container Registry patch existing container images without actually needing access to the image's original source code to perform a full rebuild? How does it do that? Well, once you've configured registry auto-patching, what Azure Container Registry will do is, for an existing stored image, it'll continuously scan the images with Trivy, an open source vulnerability scanning tool. This will highlight any vulnerable system packages that are lurking within those images. Afterwards, ACR will use Copacetic, an open source patching tool, to patch those container images. So what ACR does here in this key step is it leverages Copacetic to run the Linux package update manager within your container images, updating any outdated and vulnerable system packages that are lurking within your container image. Finally, at the end of the auto-patching process, Azure Container Registry produces a new patched image, the new auto-patched image, with its own digest and tag. This whole process ensures that a secure patched version of your container registry image is available for downstream consumption. But that's only half the story. So ACR is now continuously scanning and monitoring and producing patched versions of your container images. But how do you actually get your downstream builds and deployments to now consume the patched image instead of the vulnerable existing images? Well, how many of you have dealt with, how many of you are release managers here? Dealing with new version releases? A couple of you guys here. You all know that this is a very tedious process whenever you have to do a release. You have to remember to bump up your downstream build scripts, your downstream deployment manifests to consume a new patched image, and also to remember to kick off the downstream deployment pipelines. With Dependabot, this whole process is automated away. So whenever ACR produces a new auto-patched image, what happens is Dependabot actually opens PRs in your downstream Dockerfile builds, in your downstream Kubernetes YAML manifests, or your downstream Helm charts, suggesting that you consume the new ACR auto-patched image instead of your existing vulnerable image. This ensures that the latest registry auto-patched images are propagated downstream and consumed all across your organization, all without much manual overhead. Now let us actually see this in action. So right here, I have a Kubernetes manifest that deploys a container image. It's just a standard Kubernetes manifest YAML. And right here, I am deploying an Nginx application right from my Azure Container Registry. So in this case, in the highlighted line, I am actually deploying the Nginx 127.1 container image. Very standard setup. Let us actually see if there are any vulnerabilities lurking within. Well, when I ran Trivy to scan the container image, lo and behold, I see that it has 10 vulnerabilities lurking within. Oh no, alarm bell's ringing off. How do I actually get this image secure? How do I actually have a new patch version of the container image if there's no upstream fix available, or if the partner application container image publisher is actually on a slower release cadence? Well, with registry auto-patching, you can automate and secure your container images, your existing container images residing in your ACR with just this single command. So right here, when I run the command, I'm actually instructing ACR to continuously scan and patch the Nginx image residing in my registry, the Nginx 1.27.1 image specifically, and I'm instructing it to continuously produce new patched and secure versions of it whenever there vulnerabilities are detected within. So skipping ahead several days, I can see that Azure Container Registry has actually generated several patched versions of my container image. So with continuous scanning, every time a vulnerability is detected, the ACR patching task kicks in. It generates a new container image that addresses any existing vulnerabilities that ACR has detected, and creates the patched image as a separate tag and digest within your registry, thus ensuring that your existing container images have a patched version available for downstream consumption. But again, that is only half the story. I want to actually propagate this secure image downstream. As I mentioned earlier, every time a new ACR auto-patched image is produced, Dependabot proactively opens pull requests in your downstream Docker files, Helm charts, and Kubernetes manifest YAMLs, suggesting that you consume the new auto-patched image. In this case, Dependabot is asking me to accept this PR so that I consume and deploy the latest registry auto-patched image instead. And when I actually run Trivy to scan the latest auto-patched image, the 127.1-2 auto-patched image, there are 0 system vulnerabilities within. Hooray! I've just gotten green without much effort. So you've now seen Azure Container Registry auto-patching in action. This feature is now in preview. You can learn more about how you can secure your existing container images right at the QR code. You can scan that right there. Let Azure enable your IT engineers to remediate urgent vulnerabilities without requiring a full rebuild from source. Let Azure automate the otherwise very tedious process of remediating container image vulnerabilities, all without additional overhead.
Thanks, Johnson. Great to see how we can. Yeah. All right, it's really great to see how we can use auto-patching in the container registry to reduce toil on developers, to ensure that the images that you deploy out into production are secure and have no vulnerabilities. Of course, the last stage of any secure lifecycle is taking care of what's actually out there already running in production. CVEs happen all the time. They don't just happen on the way towards an image being built. And we need to discover misconfigurations and other vulnerabilities, as well as prioritize the alerts that we're getting on our running applications. And to talk more about how we can securely operate and monitor, I want to invite Laura Goldstein onto the stage, and she's going to talk to you about Microsoft Defender for Cloud.
Thank you. All right, so now we are shifting gears to the cloud security point of view to understand the challenges that our cloud security professionals have when monitoring and operating the full application lifecycle. And before we even start to talk about what is Defender for Cloud, I wanted to set the stage. Let's talk about the challenges that our cloud security professionals are dealing with every single day. First, we know that there is an increased attack surface As we move more and more applications and infrastructure into code repositories and CI/CD pipelines, these resources are also becoming attack vectors. So when you have to secure pipelines, repositories, and the actual running applications, it can be overwhelming for any security team. Next, we know that there is a huge problem with tool sprawl. One thing that my customers have in common is that they are using multiple disconnected security tools, especially for scanning their code. And this is really problematic because when you use too many tools, you don't have a way to consolidate the insights from each tool, and you don't get a holistic view of the security posture of your environment. And with lots of tools, we're also dealing with way too many security alerts. I'm sure you're all buried with security notifications of what you have to fix and what vulnerabilities you need to prioritize. And when you're dealing with too many alerts, that actually means the critical ones are probably being missed because they're buried amongst the less important ones. And then lastly, we know that there's a huge challenge between dev and security silos. Development and security teams, they've never been the best of friends because they have different goals and objectives. And with this, we are finding it really difficult to address security issues earlier in the development lifecycle, and security is often seen as a blocker, and they have to work on last-minute fixes that disrupt production. So now we know the problem, let's talk about the solution, which is Defender for Cloud. We're releasing 4 new capabilities in Defender for Cloud, which is our cloud-native application protection platform. These capabilities are all meant to help you reduce your risk and strengthen your relationship with developers. First, to increase the to counter the increased attack surface, we've developed a new capability that gives you instant visibility into vulnerabilities across all of your code repositories called agentless scanning. So not only are we already ingesting security alerts from GitHub Advanced Security, but we're also now providing you with infrastructure as code and security posture management recommendations directly in Defender for Cloud to help you identify weaknesses in your code. And by the way, to get coverage for this, you don't need to configure anything. Once you have a connector in Defender for Cloud to Azure DevOps, we will automatically scan your code repositories for any sort of vulnerabilities. You don't even have to work with developers to add steps within the pipeline. But when we bring in all of these vulnerabilities, we know it can be overwhelming. We've already talked about alert fatigue, and this leads to those critical issues being missed. So what we're doing with this is we're really excited to release a new partnership with Endor Labs for advanced exploitability analysis for your open source dependencies. This helps you prioritize based on code reachability to cut through the noise and highlight the most urgent risks. With Endor Labs' advanced software composition analysis capabilities directly integrated into Defender for Cloud, combined with our existing integrations with Dependabot that we've heard so much about already, Defender for Cloud is truly empowering organizations to consolidate application security and cloud security into a single pane of glass that has reachability analysis provided from code to runtime. Also along the lines of helping you reduce the noise is we are now providing you with code to runtime traceability for your exposed secrets. This means that when GitHub Advanced Security detects a secret in your code repository, we're actually seeing, can that secret access a resource in runtime? So instead of triaging hundreds of exposed secrets where most of them may be false positives or they may have already been expired or revoked, we're saying that this secret actually has access to a resource, and that resource, maybe it has sensitive data, maybe it's exposed to the internet. We're giving you all of that context so you know truly what is the most critical points to resolve. And then lastly, since we've already talked about how challenging it can be to work with developers as a security professional and get them to remediate the issues, we're trying to ease that process a little bit by at least helping you find the relevant development teams. And we're doing this by giving you visibility into any CI/CD pipeline that actually pushes a vulnerable container image. So when you see a running container in your cloud environments, you can trace the source of that image back to the CI/CD pipeline that created it in the first place. And this is for CI/CD pipelines outside of the Microsoft ecosystem, including Jenkins, Bitbucket, and more. It doesn't matter what platform you're using, we're going to give you the same code to runtime intelligence regardless. But enough talking about this. Let's actually switch over to a demo so I can show you these capabilities in action. All right, so here we are in Defender for Cloud, which is our cloud-native application protection platform. We secure Azure, Amazon Web Services, and Google Cloud. And of course, we secure DevOps environments. So we're going to go to DevOps security here, and we can immediately see alerts coming from GitHub and Azure DevOps just within this demo environment. And we have around 1.5 thousand security vulnerabilities that have been detected. So these vulnerabilities are being detected by GitHub Advanced Security, us ingesting those alerts, and also from the agentless scanning feature that we released, where we can immediately scan for any sort of infrastructure as code misconfigurations or posture management recommendations within your code repositories. But with this visibility, it's overwhelming. If I were a security professional and I went into this dashboard and saw these numbers, I would be terrified. Where do I even start? We can start with high severity, but we have almost 1,000 high severity findings. So maybe we'll just focus on one of the categories. So we can look at dependency findings. We have 341 dependency findings. Remember that number for later on when I switch over to a different part of the demo. So now we know we're overwhelmed, we need to prioritize. So let's actually go to attack path analysis, which tells us where we're most at risk. And here we can see this attack path that says we have an internet exposed container that has high severity vulnerabilities, and it allows lateral movement to a Kubernetes cluster through a service account that's assigned to that container. And on this attack path, we can see something brand new, which is reachable vulnerabilities. This information comes directly from Endor Labs, and it tells us that instead of just having an open source dependency that's listed on a manifest file that we don't know if it's actually part of the application, Endor Labs was actually detecting that this dependency is not only used in the application, but there is a direct path from your first-party code that is used to access the vulnerable part of that dependency. So we know it is truly exploitable, especially with the runtime context, knowing that this container is internet exposed. So with this information and the fact that we're able to gather it because we can see that the repository creates the container image in the first place, we at least have a little bit of a better idea of how we can go about remediating this. And with everything that Johnson just showed us, we know the remediation is getting much simpler as well. But one thing I do want to point out before we switch gears is that right here we see that an Azure DevOps repository pushed this container image. But this isn't going to be unique to Azure DevOps or GitHub anymore. We now can see, does a Jenkins pipeline push an image? Does a Bitbucket pipeline push an image? We're extending this support for any CI/CD pipeline. All right, so this is attack path analysis, and it's powered by this underlying security graph that powers many features in Defender for Cloud. And we can actually write queries over the security graph using Cloud Security Explorer. So here I'm just going to show you one query, because remember before we were talking about how there were 341 open source dependency vulnerabilities. We're going to see how we can actually narrow that down using the data coming from Endor Labs. So we're going to write a query to say code repositories that contain vulnerabilities that have actually, the reachability level is a reachable function. So when we write this query, instead of having 341 open source dependencies that we need to remediate, we're actually narrowing it down to maybe around 20. And right now, we're not even filtering for high or critical, so we can actually add that in as well. And this brings us to, I want to say it'll be around 3, or 4 or 5 if you count these as being different, since they're part of different repositories. So we're massively reducing the amount of work that you actually need to prioritize, and we're showing you what is actually exploitable and what attackers would be able to compromise if they did get access to your environment. On the vulnerability itself, you can see that the source is Endor Labs. You can see it's rated as critical severity. We can see the exploitable probability score percentile. It's a reachable function. And we can see the actual calls being made from my first-party code all the way to the vulnerable portion of the dependency. So I hope that would help you understand how we can actually reduce the amount of noise that you have to focus on. But moving on to the next part of the demo, I briefly want to touch on the secret mapping capabilities. So using the Cloud Security Explorer again, and we know we have different sorts of exposed secrets in our environment, we can quickly search for code repositories that contain secrets. And we'll look for shared access signature tokens here that can actually authenticate to storage accounts, and these storage accounts contain sensitive data. So instead of just knowing we have exposed secrets, we're actually pointing those secrets to the storage accounts or other resource types that they can access, knowing that those resource types contain sensitive data, and we're able to see the exact details that we need to remediate this, including the file path and the alerts that are coming from GitHub Advanced Security. All right, let's go back to the deck. So I hope by the end of this, you're starting to understand how Defender for Cloud, combined with Azure Container Registry Security and GitHub Advanced Security, can help bridge the gap between development and security teams. In Defender for Cloud, we're really focused on decreasing the attack surface, consolidating tools into a cloud-native application protection platform, helping you prioritize critical alerts based on cloud context, and promoting dev and security partnerships. These tools should be your one-stop shop to securing your software development lifecycle. All right, and then if you want to learn more, definitely come to check out our session tomorrow, which will be around specifically on Defender for Cloud. It's going to be at 11:30 a.m. Central Time. Back to you, Brendan.
Thank you, Laura. Oh. Perfect. Thank you. Thank you so much, everybody, for coming, and thank you to our presenters who did all of the hard work. I hope you've learned about how we can combine security with development and operations to enable DevSecOps and all of the great products that we have end-to-end, from GitHub and code to container imagery patching to Microsoft Defender for Cloud. And I encourage you to go check out all of the follow-up sessions that were highlighted. Thank you so much for attending, and we'll see you again at the next Ignite.